Product and quotient rules, part 4. If f of x is equal to the square root of x times h of x, where h of 2 is equal to 4 and h prime of 2 is equal to 3, find f prime of 2. Remember that when we're doing these problems, we have to find the derivative first before substituting. So we have f prime of x is equal to, well, this is a product. And actually, for some people, the derivative of the square root of x doesn't jump out yet, so let's just rewrite this real quick, just rewriting f of x. So we have x to the 1/2 times h of x. And now we'll use our product rule. So f prime of x is equal to the first function, which is x to the 1/2, times the derivative of the second function, so that'll give us h prime of x, plus the second function, h of x times the derivative of the first function, which will be 1/2 x to the negative 1/2. Then we'll just rewrite this, so we have the square root of x times h prime of x plus h of x times, well, h of x over 2 times the square root of x. And now we can substitute to find f prime of 2. So we have the square root of 2 times h prime of 2, which will be 4, plus, 3, plus h of 2, and this is what 4 is, over 2 times the square root of 2. So this will be equal to 3 root 2 plus one of our 2's will divide out, so we'll just be left with 2 over root 2. If you wanted, you could rationalize this. So equivalently, this is 3 root 2 plus 2 root 2 over 2, which is equal to 3 root 2 plus root 2, which is equal to 4 root 2. Which is definitely a better answer. But if you're pressed for time, we're most concerned, typically most instructors are most concerned with you being able to find the derivative. If f of x is equal to e to the x over h of x, where h of 2 is equal to 4, and h prime of 2 is equal to 3, find f prime of 2. So here we have a quotient, so we will need to use quotient rule. So, taking the derivative before I substitute, I have that f prime of x is equal to low, which is h of x, d high, the derivative of e to the x is e to the x, minus high, which is e to the x, d low, the derivative of h of x is h prime of x, all over low, so all over h of x, all squared. Then I can substitute, so f prime of 2 will be equal to h of 2, which is 4, times e to the x, minus e to the x times h prime of 2, which is 3, all over h of x squared, so all over 4 squared. If I have 4 e to the x's and I subtract 3 of those e to the x's, I am left with 1 e to the x, keeping in mind that actually I should substitute 2 in for these guys as well, so these are e squareds, all over 4 squared, which is 16. So f prime of 2 is equal to e squared over 16. Suppose f of 3 is equal to 1, f prime of 3 is equal to negative 2, g of 3 is equal to 4, and g prime of 3 is equal to 2. We want to find f g prime of 3. So what this is saying is we want to find the derivative of f of x times g of x. So fg is a product. It's f of x times g of x. So this will be equal to, using our product rule, f of x times the derivative of g of x, so times g prime of x, plus g of x times the derivative of f of x, which is f prime of x, and then we want to substitute in 3. So we have f of 3 times g prime of 3 plus g of 3 times f prime of 3. F of 3 is equal to 1, g prime of 3 is equal to 2, plus g of 3 is equal to 4, and f prime of 3 is equal to negative 2. So this is equal to 2 minus 8, which is negative 6. So that is what fg prime of 3 would be equal to. Now to find f over g prime of 3, so that's finding the derivative of f of x over g of x, so we have a quotient rule here. So we have low, so that's g of x, d high, f prime of x, minus high, which is f of x, d low, so the derivative of g of x, all over low low, so all over g of x all squared. And then we want to find then this value at 3, so that'll be g of 3 times f prime of 3 minus f of 3 times g prime of 3 all over g of 3 all squared. So this will be equal to g of 3, which is 4, times f prime of 3, which is negative 2, minus f of 3, which is 1, times g prime of 3, which is 2, all over g of 3 squared, and g of 3 is 4. So that's equal to negative 8 minus 2, which is negative 10 over 4 squared, which is 16, which simplifies to negative 5/8. So that is what f over g prime of 3 is equal to for this particular function. Well, particular set of functions. Now we have a problem that's very similar to the last one, but instead of having f over g, we have g over f. So we have low, which is f of x, d high, which is g prime of x, minus high, d low, so that's high is g of x, d low is f prime of x, all over low low, so all over f of x all squared. And we want to evaluate this at 3, so that'll be f of 3, g prime of 3, minus g of 3, f prime of 3, all over f of 3 squared. F of 3 is equal to 1, g prime of 3 is equal to 2, minus g of 3 is equal to 4, and f prime of 3 is equal to negative 2, all over f of 3 squared, and f of 3 is 1. So this is equal to, let me have the right color, equal to 2 plus 8 over 1, which is equal to 10. So g over f prime of 3 is equal to 10.